we're moving forward into linear functions. Perpendicular distance is the name of what we're doing. It's really shorthand. It means perpendicular distance between a point and a line. But as you can see, it's a bit of a mouthful, so that's why we just say perpendicular distance, because let's just think about this. If you have 2 points, well, kind of the only real distance between them is the perpendicular, like what perpendicular to what? And what other kind of distance do you mean? Do you mean like, ooh, that distance, right? We only mean that straight line distance. When you've got a point and a line, the reason why we say perpendicular distance and not just distance is because, or if you have a line, like say this one I've already drawn over here, and you define some arbitrary point, right? When you say, well, okay, how far is that point away from that line? The answer is, it's as far as you want it to be, because, I could say this is the distance, or I could say this is the distance, or this is the distance. I could go any point on that line and get a distance, right? So therefore, the only unique way to talk about one distance, the distance, is to say, I want the shortest line. I want the shortest distance between that point and that line. And the shortest distance is the perpendicular distance. Just like if you're crossing a road, the fastest way to get across is to cross perpendicular to the direction of the road, rather than kind of go at an angle, right? So therefore, that's what perpendicular distance is referring to. Now, I'm going to do something a bit unusual, which is I'm just going to give you what the formula is right off the bat, okay? And then we're going to prove it after that. I usually like to do it the other way around because it's kind of like, logic. Where does the formula come from? It comes from the proof. But because the formula, as you'll see, and some of you are familiar with it, looks quite awkward, I'm just going to give it to you so that when we prove it, you'll be like, oh, okay, I can see the pieces starting to form. So here's the formula. It's the absolute value of ax1 plus by1 plus c, absolute value, all over the square root of a squared plus b squared. So there's a couple of things to know. You have a look at it. What are the pieces that go into this? The first easy piece to identify is you've got x1 and y1, which clearly are talking about this point, right? So when there's like some point and some line, the point is x1, y1, right? Not to be confused with x and y, which are variables, right? So this is some actual values. When you look, what are the rest of the pieces? Don't get overwhelmed by how much stuff there is. Yeah?
The square root of a squared plus b squared is because it's perpendicular and there's a 90-degree angle.
Okay, good. Good. When you look at this, like, that's always got to make you raise an eyebrow and say, what's going on with that? Clearly Pythagoras is involved, and the reason Pythagoras is involved is because there are things that are at right angles. Okay, so we'll get to that. As for the pieces that go into Pythagoras, you've got A, B, and C. What do you think the A, B, and C stand for? Yeah.
The formula of the line.
Yeah, good. We've already got the point covered, right? We want the line, and so that line is ax plus by plus c equals 0, general form. Okay, so that's the A, B, and C. That are these A, B, and C. Okay, so there's the formula. One other little thing to notice, there's an absolute value there on the numerator. Why is that? Because it's a distance, right? So I want a positive value. As opposed to that other distance formula that you know, where you just have 2 points, right? The other distance formula doesn't have an absolute value sign on it because it's just the square root. Like, it's just the square root of this plus this. So by definition, it's positive, right? But as you can see, it doesn't take that much effort to pick out a combination of A's and B's and C's and X1s and Y1s, such that you get a negative on the top and you'll be like, uh-oh, I want a distance, okay? So that's where we're going to end up. To get there, your textbook has a proof of this result. There's loads of proofs of this result. It's a good proof. It's very algebraic. It's very algebra heavy. And I'm very conscious of the fact that you've been doing quite a little bit of algebra already, right? So here's what I'm going to do instead. I'm going to show you a slightly different proof. You'll need a set of axes, so draw one up with me. Just for simplicity's sake, let's just do a basically first quadrant diagram. So that's not a good pen to use. We could use more quadrants, but we only need one to really illustrate what's going on. Alright, so here's my first quadrant, roughly speaking. I said that I'm trying to avoid a proof that's super algebra heavy. Obviously, we're not going to avoid algebra completely because it is algebra, right? But what I'm going to try and do is try and flex your geometric thinking muscles, okay? This is going to be more visual heavy and reasoning heavy than algebra heavy. In fact, in terms of like sheer lines of working, it's about a third the length of the other proof, okay? But you have to think a bit harder to see where the pieces come from, right? So that's the trade-off I've made. In our first quadrant, let's draw a particular point and a particular line. Now, I have to have like it locked into a particular example. So I'm just going to put a line like that. I'll call that my ax plus by plus c. Okay. And I'm going to pick a point, and just because I've got space over here, I'm going to pick the point over here. Let's call this, let's call it P for point. And its coordinates are x1, y1. All right, so far so good. So what I'm after is the distance that's shortest between this point and this line. And you can draw it on, right? It's the distance such that you draw an interval, so you get a right angle with the line. It's going to look like this. And there's our right angle. Okay, that's the actual distance that I'm after. So I'm going to call that distance d, lowercase. Okay. All right, now, where are we going to go from here? I need to know a couple of pieces here. I'm going to add some pieces in here, which seem a little bit arbitrary, but you'll see the direction I'm going in and how I'm trying to use these geometric features to my advantage. Okay, so from my point P, I'm going to drop a vertical line down from P down to my actual line that I'm interested in. So it's going to be vertical, parallel to the y-axis. So on my diagram, it's going to look something like this. Like that. Okay, so what I have formed is a triangle, and I'm going to do some work with this triangle, so I want to label it, I want to have some names here that I can talk about. So I'm going to call it triangle PQR. Alright? Now, if this line is vertical, right, just for the sake of clarity, I'm going to say that that's parallel to this y-axis over here, right? Okay, before I put any more constructions on, this point R over here, actually both Q and R, I can work out their coordinates. Q's a bit tricky because of this right angle business, but R is not hard to work out. For instance, what's the x coordinate of R? It's just x1 because it's vertically, directly underneath P, right? So that's easy. The y coordinate, it's a little bit messier, but it's not that hard. Let's take our ax plus by plus c, and let's put it in a form that'll make it a little bit easier to work out what this coordinate is, okay? So for instance, if I make y the subject, I'm going to get by equals minus ax minus c, right? So if I make it the subject, I've got this. So now, what's the y coordinate of this point R? It's just going to be minus ax1 minus c all over b. Does that make sense? Right? It's this line, right? But it's this particular point on that line, okay? So instead of x, I have x1. That's my actual x value. Does that make sense? So I'm taking my x value, I'm subbing it into the line, and that gives me this corresponding y coordinate. Are you with me so far? Okay. You see what I mean by I'm trying to do less algebra and I'm trying to do more geometry and see if you can follow what's going on. So that gives me this coordinate. Okay. So far so good.